This is an endpoint security demonstration of CPU-based threat detection and remediation of criptojacking attacks leveraging Microsoft Defender for Endpoint, enabled with Intel Threat Detection Technology, part of Intel Hardware Shield available on the Intel vPro platform. In recent years, cryptocurrencies like Monero have increased in value, causing attackers to shift their focus to criptojacking, resulting in a 53% increase in attacks. This malware uses the computer's power and resources to mine for cryptocurrencies, resulting in a slowdown of the user's PC, or a Trojan may also deploy for a more malicious attack payload. As news headlines have shown, attackers have successfully evolved to evade typical anti-malware defenses with techniques such as cloaking in a virtual machine, binary obfuscation, or memory-only payloads. To illustrate different attack vectors, we first show Scenario 1, where an unsuspecting user downloads crypto mining malware masquerading as a system scanner utility tool. In Scenario 2, we show a more advanced attack launched in a virtual machine where typical anti-malware defenses have less visibility. The Intel CPU provides full-stack visibility and monitors telemetry coming from the applications and the virtual machines at runtime. Intel Threat Detection Technology applies machine learning to the CPU telemetry and detects malware code execution fingerprints irrespective of obfuscation techniques. The machine learning inference and other performance-intensive security workloads can be offloaded to the integrated GPU, enabling continuous monitoring with negligible overhead. After filtering out false positives, Intel Threat Detection Technology signals the attack to Microsoft Defender for Endpoint, which can apply numerous remediation countermeasures, including killing the malware process. The entire kill cycle happens in seconds, preventing impacts to the user's machine while preserving the user's computing experience. Now, let's view the functional demo. The user's machine has Microsoft Defender for Endpoint enabled. The user downloads a utility scanner and selects to execute the file. A crypto miner launches as represented by the black dialog box that would run hidden in the background. As the crypto miner steals compute resources to mine for cryptocurrency, we see the user's machine throttling up CPU usage. In the lower right, we also see that Microsoft Defender has blocked the attack after gaining the Intel Threat Detection Technology signal coming from the CPU. If we look into Microsoft Defender's protection history, we see the associated attack metadata, such as killed process ID and file hash. In Scenario 2, we illustrate the advanced attack scenario where the malware cloaks itself in a virtual machine to evade anti-malware defenses that have less visibility when deployed outside the VM. Here again, the user has launched the scanner utility, which launches the virtual machine and starts the malware execution as shown by the black malware dialog box. This would typically shield the malware from the host OS defenses deployed outside the VM and would consume CPU cycles. With the full-stack visibility provided by CPU-based threat detection, Microsoft Defender detects and kills the attack, preventing it from spreading across the network or fleet. Learn more about CPU-based threat detection, Intel, and Microsoft solutions.